Hello students, welcome once again to Dr. Saurav Sir's classes. We are back again with the group theory videos. Yeah, we were doing videos on group theory. We're doing the theory part. Okay, and we had completed quite a lot in this. Okay, so you have been going through, if you have been going through these videos, you know that we have learnt a lot in group theory. Okay, we are enjoying these classes, I hope so. Okay, I know that you students must be thinking there's so much to learn in group theory, but then let me tell you, when we go on to the mathematical part, you will find it relatively easier than what you are learning, and you will find that you can relate these things to your mathematical part. Okay, so don't worry about the theory part or the problems that you're facing in the theory part. Okay, when we will do the mathematical part, you will see you can relate with the theory. You can relate the mathematical part with the theory part. So let's go ahead and see what we can do, what we are going to do in our topic for this part. We are going to do about examples of some cyclic group. You remember I taught you cyclic group in the previous video. Okay, so how is a cyclic group? Any group that can be generated by a single element, right? In the previous video I showed you what is a cyclic group, right? And its generator says B. It's written in this way. Okay, so the first one will be examples on cyclic group. Next, examples of non-cyclic group. Since there are cyclic groups, they have to be non-cyclic groups. So we will do some examples on non-cyclic groups as well. Then we will do some important results, some important rules that you need to follow, properties of cyclic group. Then we learn about Euler's phi function. Okay, phi function. Okay, then we will learn the center of a group. Then we are going to learn some results on center of the group. So this part stopped. Okay, so moving on to our first part is the examples of a cyclic group. Okay, so let me just put this into the screen. Yeah, now you can see better. Examples of a cyclic group. The first example. Going on to the first example. What is the first example? The multiplicative group 1, minus 1, I, minus I, formed by the fourth root of unity, is a cyclic group. Okay, so this is a cyclic group because it has a generator. Okay, that will generate the group. So finding the generator is your work. Okay, something that I want to give you. Try and see which is the generator from here. Like if you go on to the second one, you will notice that omega is the generator. Why? Look, the multiplicative group, this is a multiplicative group. Okay, the first one is a multiplicative group, so you can just do the multiplication and write 1 minus 1 I minus I. Okay, you know how to do. I'm not going to tell you how to do, because if I give you all the examples, then you will not try anything at home. So please try. Okay, try. Like I have showed you examples, try. You also try on your own. Okay, you can search the internet, you can search anywhere you like. You will find many results as such. Okay, but you have to try. Go ahead, go back home and try these examples with mathematical examples. The theory, I know it's group theory, you have to remember a lot, but you can also understand it by giving your own mathematical proof. Okay, alright, moving on to the next one. The multiplicative group 1 omega and omega squared, formed by the cube root of unity, you know that they are the cube root of unity, is called a cyclic group generated by omega. So when you do this, it's a multiplication 1 omega square, again 1 omega and omega squared. Then when you multiply 1, then you have omega, then you have omega squared, then you have omega, then you have omega squared, then omega cube is 1. Okay, then you have omega square, right? Then you have 1, then you are going to get omega to the power 4 means that is omega cube into omega, so omega cube is 1, so that is 1 into omega is omega. So you can see how omega is generating this group. Okay, you can see how this omega is generating the group. Is the generator. Okay, omega is the generator. So let's go on to the next one. The group Z of integers, the group Z means Z is integers under addition, is an infinite cyclic group generated by 1 or minus 1. So the group of Z, group of integers Z can be generated, it's an infinite group, infinite cyclic group. It can be generated by 1 or minus 1, right? Isn't it? Because in a cyclic group, what if there is an element, okay, that will exist and belong to the group B. Okay, suppose an element is there that will belong to group G, sorry, I'm saying B, such that every element of this group is the power of B. Every element in this group is to the power of B. That was the definition for cyclic group, right? Power of B. So this one and minus 1 can be used as generators. Okay, so everything, look at this. Let's say let's say 3 to the power 1. It can be generated, right? Isn't it? You can generate this also. Okay, so 1 or minus 1 are the generators here. Moving on to the next one, Zn. Okay, with addition, this is okay. This is under addition. They can be generated with 1 or minus 1. So with addition you can generate that. Alright, make sure you understand the difference between the addition and the multiplication here. Okay, the group of Z of integer, you might say, sir, 3 to the power minus 1 I cannot generate because that will become 1 by 3. But then that is not what it's saying. It's saying the integers under addition is an infinite cyclic group with a generator 1 or minus 1. When you do addition, say 1, 2, 3, 1, 2, 3. Addition with whatever modulo you have, say 4. Okay, then 1 plus 1, 2. Then over here 3. Then 3 plus 1, 4, 0. So like that. Okay. 1 minus 1 will be the generators. With 1 I showed you over here. Okay, you don't have to worry about this. When we go on to the mathematical part, everything will be clear and everything will be explained. Okay, so don't take tension that the theory is going over here and I cannot understand. You can just go ahead and look for examples in the internet, but then there is no need to do that because we will be covering everything over here. I will be giving you examples on cyclic group with mathematical parts too. Okay, moving on to our next topic. Zn of all n is a cyclic group of order n under addition modulo n. Okay, so Zn is a cyclic group. Okay, students. So I don't think that explaining that is enough. Let's give you an example. Just hold on. Just give you an example for number 3. Let's say the group of Z is saying for number 3. Okay, let's go back to number 3. I want to give it. Just hold on. Instead of rubbing off that thing, I'm just scratching it. I'll give you a mathematical example. Okay, don't worry. I'll give you a mathematical example. I'll solve the problem here only. I'll try and solve the problem here. The Z, it said the group Z of integers under addition is an infinite cyclic group generated by either 1 or minus 1. Look at this. Suppose I want to generate number 3. It is an integer, right? It belongs to Z. How do I generate number 3? 1 plus 1 plus 1. Isn't it? I can also generate it as suppose I want to generate -5, then what do I do? -1 plus -1 plus -1 plus -1 plus -1, 1 2 3 4 5. So that's why it is saying these are the generators. Understood? No, how they are generating the group. Okay, how they are generating the group of addition of integers, how they are generating the group of integers is actually what it's trying to say. Okay, so that's how you're going to get the generators. Okay, so if you say suppose if I ask you minus, where is that pen, stupid, -10 belongs to z, right? So how are you going to generate -10? Of course, -1, again -1, -1, -1, like that. You'll go ahead 10 times, right? And then you can generate that. So that's why it is saying that -1 and 1 are generators of z. Okay, under addition. Did you understand? Now I gave you a simple mathematical example. I told you these are very simple things. When I go ahead with mathematics of group theory, okay, group theory is just not theory. Okay, there is mathematics too. Don't think that I'm going ahead with theory. That's why if I go back to the first page, it's written theory. That means there is also mathematics. Okay, so don't worry. So moving on to the next one, what does it say? It says Zn for all n is a cyclic group of order n under addition modulo n. Okay, all n's. Moving on to the fifth one, 2z is equals to 0 plus minus 2. 2z means plus minus 2 means integer, so it will be a negative and positive. Plus minus 4 plus minus 6 and so on. It is also a cyclic group generated by either 2 or -2. You can see over here it's 2z, right? Under addition, now I hope you have understood, like 2 if you need, so 2, and if you need 4, then you will do 2 plus 2. Okay, if you need 6, then you will do 2 plus 2 plus 2. So they are the generators. Okay, also m of z plus is a cyclic group generated by either m or minus m under addition. Okay, under addition, so m or minus m means you'll have m plus m plus m, or minus m minus m minus m, and so on, like that. Okay, so students, in this part I have done with the examples of some cyclic group. Okay, don't worry, this is not enough for the examples. There are more examples to cyclic group which we will be continuing in the next video. Okay, and there is even more on cyclic groups. Okay, so please go through this topic: cyclic groups, abelian groups, okay, generator of groups, order of groups. They are very, very important parts. Okay, go through them, learn the theory, understand and learn the theory, what I mean to say. Okay, and once you understand and you have learned the theory, go ahead and watch our videos for mathematical part, where the mathematical part is going to help you in many competitive exams. These type of questions come in many competitive exams. Alright students, so that's it for this video. You keep taking as much help as possible from Dr. Saurabh sir's classes, because all the help that you will be needing will be provided here at Saurabh sir's classes. Okay students, and don't forget to watch our views, watch our videos, like our videos, subscribe to our channel, and do whatever you want to get the most help possible. Thank you students, thank you for watching.